What are the adaptations of marine mammals when dealing with gaseous exchange? In order to survive under the sea, marine mammals have a large lungs than terrestrial animals. With a large lung, it helps in providing the buoyancy for swimming and give a larger tidal volume. Besides, the marine mammal also increases their oxygen storage by storing it in different areas, such as in the lung, muscle, and blood. For example, they have increased their volume of red blood cells and hemoglobin, which are important components for respiration. Last, the terminal portion of the airways in all marine mammals are supported and reinforced by cartilage or muscle. This is to provide a less collapsible region into which alveolar gases can be forced during a dive to prevent gaseous exchange with blood at high blood pressure. Thus, this can to keep the terminal airway open even at high flow rate of gases in and out of the lung during a breath, and to allow high expiratory flow rate even as the lung volume decreases.
What are the adaptations that allows marine mammals to live underwater with high pressure? For diving marine mammals, these present two problems, which first, air is buoyant, and second, air is easily compressed, leading to a potential collapse of the lung. So, the adaptation to this problem is, first, most marine mammals have lungs that are able to collapse and reinflate easily. They tend to be long and tubular with built-in protective rings to keep the valve open. Also, marine mammals tend to exhale right before dive. Marine mammals have very muscular and efficient lungs which can exhale up to 90% of the air in the lung in any given breath. Thus, by removing the air from the body, diving marine mammals has a very little problem with changing pressure because no air, no problem.
So how does whale sleep? Unlike human beings, humpback whales are conscious breathers, which means they have to remember to breathe even while sleeping. According to Animal Planet, it's believed that humpback whales only shut half of their brain at a time while asleep, so as to be alert enough to breathe. Some humpback whales have been documented sleeping upside down, while others have been spotted sleeping horizontally, floating either near the surface or farther underwater. In general, dolphins and whales have two basic ways of sleeping, according to the Scientific American. They either rest quietly in the water, vertical or horizontally, or sleep while swimming slowly next to another animal. So here is a picture of a pod of sleeping sperm whales where they are floating vertically with their tails down. So that's how a whale sleeps.
Okay, so now I'll talk about what is decompression sickness. Decompression sickness is also known as generalized barotrauma or the BANS. Depression sickness is the injuries caused by a rapid decrease in the surrounding pressure of either air or water. It occurs mostly in scuba or deep sea divers, but in rare cases it also can occur during high altitude or unpressurized air travel. So now I'll explain an example case of what decompression sickness looks like. When you scuba dive with compressed air, you take in extra oxygen and nitrogen. So the oxygen is used up by the body, while the nitrogen is dissolved into your blood, where it remains during your dive. As you swim back towards the surface after a deep dive, the water pressure around you decreases. If this transition occurs too quickly, the nitrogen does not have time to clear from your blood. Instead, it separates out of your blood and forms bubbles in your tissues or blood. It is these nitrogen bubbles that cause decompression sickness. If the nitrogen bubbles form in your blood, they can damage your blood vessels and even block your normal blood flow. This condition is called the BANS because the joint and bone pains can be so severe that they double you over.